Okay, hello. This is the questions and answers on chapter 1 on states of matter. Hopefully you have gone and studied the notes on chapter 1 and looked at the questions and at least tried them. They should be easy, so you should have been able to do most of them. Okay? The first question that you have in there is complete the diagram, show the arrangement of particles in a liquid. So he's saying he wants a liquid, so you should be able to draw circles that are touching somewhere, far away somewhere. We said they are near each other in clusters if we're talking about a liquid, so your diagram should look something like this. Were you able to do that? Okay. 3 states of matter are solid, liquid, and gas. The diagram shows how the particles are arranged in each of these states. And he has arrows. So first of all, take note of the direction of the arrows. X is going from where to where? From liquid to gas. So X is boiling. Y is what? It's going the other way around, from gas to liquid. Gas to liquid is condensing. And Z is going from liquid to solid, so liquid to solid is freezing. Were you able to do that? Okay. Which statement best describes the movement of particles in a gas? So let's look at the choices. The first one says particles vibrate about fixed positions. Does that apply to a gas? You should realize that this does not apply to a gas. It applies to solids, so A is wrong. Particles slide past one another. This applies to what? This applies to liquids, so this is not the correct one. Particles move freely. Now this should be our answer. Now when you're choosing from these choices, even if you see that C is correct, please go on and check that the others are wrong to make sure that your answer is the correct one. So D says the particles do not move at all. Is that correct? Remember we said we cannot say particles do not move at all. Particles are always moving. So in this case, my answer is C. You know that in Edexcel, they put boxes next to the choices and you're supposed to put a cross in the correct box. A student investigated what happened when a sample of wax was heated using a Bunsen burner, and this is a diagram of a test tube with the wax being heated. The student heated the solid wax strongly with a Bunsen burner until it turned into liquid. So he's saying give the name of the process that occurs when a solid turns into liquid. Solid turns into liquid. And you should realize that that is melting. Explain one change needed to make the experiment safer. Usually there are questions about safety in most of the questions. So here he's saying, how do I make this experiment safer? So what are we doing? We're heating a solid in a test tube. If we heat it directly, the solid is likely to splash out or pop out or things like that. So when we're heating a solid in a liquid, we should not heat it directly. We should heat in what we call a hot water bath. Hot water bath means putting the test tube in a beaker containing water, and it is the beaker and the water that has been heated, not the test tube directly. So this prevents the wax from boiling over. Describe the changes in arrangement, movement, and energy of the particles when the liquid wax cools to become a solid. So we need to explain arrangement, movement, and energy. You should realize that we're talking about liquid cooling to solid, and that means, are we heating or are we cooling? We're cooling. That means the particles will lose kinetic energy. When they lose kinetic energy, then they start to move slower. And when they move slower, they start to come closer to each other in this arrangement. Now, once they come closer to each other, they become a solid, and that means they become a regular arrangement in rows. So in this case, we have explained what happened to the energy, what happened to the movement, and what happened to the arrangement. Are we okay? Okay, this is the next question. He says a crystal of copper chloride was placed in a beaker containing water. It was left for several days. Explain how the appearance of the liquid in the beaker changes after several days. Remember, copper chloride is something that should be colored. If you remember, copper is a transition metal. If you remember from last year, copper is a transition metal, and any compounds of a transition metal have color. So copper chloride is something that has a color. When you put it in the water, what happens? The color will spread throughout the liquid, and this is by the process of diffusion. Okay, melting points and boiling points of four substances are shown. Which substance is liquid at 100 degrees? Remember, to be liquid at 100 degrees, that means it has already melted and it hasn't boiled yet, and that means that the melting point will be below 100, but the boiling point is above 100. So you're looking for something that has melting point below 100, boiling point above 100. So obviously my answer is C. But what about the other choices? Now, what is A at 100? A has very low melting point, very low boiling point, and that means that at 100 it has already melted and it has already boiled, and that means A is a gas. B also has low melting point, low boiling point, and that means it also is a gas. D has very high melting point and boiling point, and that means that at 100 it hasn't melted yet, and that means it is a solid. So my answer is C. This is the open-ended tube with hydrochloric acid on one end and ammonia solution on the other, and he's saying when they meet, identify the white solid. Remember that we said when ammonia meets with hydrochloric acid, it forms something called what? Ammonium chloride. What does the diagram show about the speed of the ammonia molecules compared to the speed of the hydrogen chloride molecules? Remember that we said if they're moving at the same speed, theoretically, they should meet in the middle. But here, in this kind of experiment, they always meet nearer to the hydrochloric acid. And that means which one is going faster? That means that the ammonia is going faster, so the ammonia molecules diffuse fast. Now, this experiment is asking, state the main hazard when using concentrated hydrochloric acid. When using concentrated hydrochloric acid, remember that concentrated hydrochloric acid is corrosive, and that's what we mean by hazard. Hazard means something that is dangerous about the experiment. So the hazard in this experiment is the fact that concentrated hydrochloric acid is corrosive. Now, the precaution I should take if I'm dealing with something that's corrosive, of course, I should wear gloves or eye goggles. This is to protect the skin and the eyes from damage. Okay, so far, were you able to do these questions? They should be easy. Now, he's saying I have melting points of 3 related compounds and their boiling points are all above 100, and he's asking me to draw a bar chart. You should know how to draw a bar chart, right? So, the first question you ask yourself, are these bars touching or not touching? Remember that in chemistry, most of the bars that we will be drawing in a bar chart are not touching. You know that they're not touching because the labeling on the x-axis are not consecutive numbers. Yani on the x-axis, you don't have 1, 2, 3, 4, 5. You have specific names or specific things that are written on the x-axis: capric acid, formic acid, palmitic acid. And that means that the bars are not going to be touching. You know that the bars have to be of equal sizes with equal intervals between them. So this is what your bar chart should look like. Okay? Then he's saying, give the physical state of each acid. Now, he already gives you the melting points, and he says that the boiling point is above 100. So capric acid, he says, has a melting point of 32, and its boiling point is above 100. Now, what is room temperature? You should know that room temperature is regarded as 20 or 25. So capric acid with a melting point of 32 at room temperature, it hasn't melted yet. So capric acid at room temperature is a solid. Formic acid has a melting point of 8. So at room temperature, which is 20 or 25, it has already melted. It hasn't boiled yet because the boiling point is above 100, so it is a liquid. Palmitic acid has a high Bordeaux melting point and a high boiling point. So at room temperature, it has not melted yet, so it is a solid. Are we okay with all of this? Okay, diagram shows a kettle of boiling water. As the water vapor cools, it turns into droplets of liquid water. The change of state when water vapor is a gas, changes into liquid. So gas into liquid is what? Condensation. So we put an X in the box next to your answer B. Okay? Describe what happens when water vapor cools to form liquid water. Your answer should include the change in energy, arrangement, and movement. So what is he doing? Vapor cooling to form liquid. And that means that I am going from gas to liquid. That involves cooling. So the particles will what? The particles will lose kinetic energy. And we said when they lose kinetic energy, they move nearer to each other. When they move nearer to each other, they move more slowly. Okay, write a chemical equation including state symbols for the sublimation of iodine. For now, let's just write this and say that if you don't remember how to write chemical equations, we have a whole chapter dealing with that we're going to explain. But for now, remember that iodine is written as I2. Now, sublimation means it is changing from what to what? From solid to gas. Solid is denoted by S and the gas by G. So iodine as a solid changes to iodine as a gas, and this is written in this way. Much more oxygen can be stored in the tank when the oxygen is a liquid rather than a gas. Give a reason for this in terms of the arrangement of particles. So he's saying he has a tank and he wants to put oxygen into this tank. Now he's saying that if I put it as a liquid, that's better because it will take more particles than if it is a gas. Of course, this is because of what? This is because as a liquid, the particles are nearer to each other. They're more closely packed. So if I have a certain volume and I put the liquid will have more particles, and more particles will be placed in that certain volume than if it were a gas. Okay? Diagram shows the arrangement of molecules in 2 of the 3 states of water. Complete the diagram to show how the molecules of water are arranged in the solid state. So he already drew liquid and gas for you. Now, as a solid, what are you looking for? You're looking for regular rows, and they have to be all touching each other. So it should look like this. You can fill the whole box, or you can just put 2 or 3 rows if you like. Which row of the table correctly describes the arrangement and movement of the molecules of water in a solid state? So in a solid state, what would be the arrangement? Is it regular or random? You should realize that if you were talking about a solid, then it is regular. So my answer should either be A or C. Can't be B or D. Now, movement as a solid, is it moving freely or is it vibrating? Right? Okay. So, as a solid, you should realize that the arrangement is regular and the movement is vibrating, and we put an X next to the C. Okay? Which word describes water changing from a liquid to a solid? Liquid to solid. You should realize that liquid to solid, that is freezing. Give the word used to describe the change of state represented by this equation. Now, this is water as a solid changing to water as a gas. So when a solid changes to gas, that is sublimation. Water is the name used for water as a liquid. Give the 2 names used for water as a gas. So water in the form of gas is called what? It's either called water vapor or it is called steam. Okay, we have 3 boxes, X, Y, and Z, and he's saying use the letters to give the starting and finishing states of matter for each of the changes in the table. So if I'm talking about ice changing to water, ice is what state? Ice is solid, and water is liquid. So which of the boxes represents solid? Z, of course, is solid, and Y is liquid. So if ice is changing to water, so we're changing from Z to Y. Solid iodine to iodine gas. He said solid is Z. Which one is gas? Gas is X. Molten iron to solid iron. Molten means liquid. So when we say molten iron, that means iron that has been heated until it has become a liquid. So the liquid changing to solid, that is Y changing to Z. Okay? Which of these changes takes place when solid iodine is heated to form iodine gas? So solid to gas, we just said it was sublimation. The diagram shows apparatus that can be used to measure melting point of a solid. The solid is placed in a small tube. The small tube is then put into a liquid contained in a beaker. This is how we measure melting point of something. So to measure the melting point of something, we put some of the solid into a small tube. We put it next to a thermometer in a beaker containing a certain liquid, and the liquid is gently heated until the solid melts. Now he's saying that when he did this to solid Q melted at 140 degrees centigrade. Explain why water is not a suitable liquid to use in this experiment. I can't use water to heat solid Q until it melts. Obviously, because what? The boiling point of water is 100. So water will boil at 100 and it will never reach the 140 that I need to reach for the Q to melt. So water boils at 100 and this is lower than the melting point of solid Q. So just why the liquid in the beaker needs to be stirred constantly. Always remember that when we're mixing something in and we're heating it, we need to mix it while heating. This is to distribute the heat equally in the liquid. Okay? Okay. We have now ended the questions on chapter 1. I hope that you were able to get all the answers, and I hope that you were able to understand what is right and what is wrong for anything that you were not able to answer. If you have any questions at any point during the course, please send me an email at drhene@mail.com or a message through my Facebook page or through Messenger. I will be able to answer you within hours of your message, as soon as I can, immediately if possible. Please send me any comments, any questions. If you're ready for a quiz on the chapter, also please send me a note by email and I will send you the quiz. You'll do it at home without looking at anything, without referring to any notes, and send it back to me by email. Okay, see you in the next lesson. Okay, bye.